All right, class. So, talking about blood pressure. So, what is blood pressure? How do we define blood pressure? Blood pressure is the pressure exerted by the blood on the walls of the arteries. That is blood pressure. I repeat, it's a pressure exerted by the blood on the wall of the systemic arteries. And blood pressure is measured by an instrument called sphygmomanometer, which is shown here. I have also provided you with the link to the YouTube video, which actually shows you how to use the sphygmomanometer to measure blood pressure of a patient. Remember, you use this instrument along with a stethoscope, and the video also shows you how to use a stethoscope and the sphygmomanometer together. Before we start, let's go over the basic parts of this instrument. You do see a cuff, right? And it's an adult size cuff. It's an adult size cuff that you see. You also have a gauge. This is a gauge. And then you have this inflatable bulb right here. This bulb is used to inflate the cuff so you can exert a lot of pressure on the artery. We also have a release valve right here. This is used to release the pressure of the cuff. And there is also a gauge holder that actually holds a gauge, so you don't have to hold it with your hands. Okay. So you might get a question on your practical exam or the quiz, and I might ask you ID this part of the sphygmomanometer. Okay, so you should know what the names of the different parts of a sphygmomanometer. Now, how does the blood pressure machine work? How does this work? To understand this, we will go over some very basic concepts. First, remember systole and diastole. What do we mean by systole? Systole is contraction of the heart, right? And then diastole is relaxation of the heart. Very good. Now, few other concepts here. Let's say this is a blood vessel. Okay, this is a blood vessel and blood is flowing through it. Now, there is no inhibition, right? Blood is freely flowing through it. The blood vessel is not constricted, and this is called laminar flow of blood. Let's write this down. This is the laminar flow of blood. Now, when a blood is freely flowing through a vessel and we see laminar flow, it doesn't make any sound. Okay, so this is a smooth flow, no sound. Now, let's do something. Let's try to constrict the blood vessel somehow. So what I'm doing is I'm constricting the blood vessel. So I'm not letting the blood pass. Okay. So the point is, so a lot of blood is here, right? Blood is here. Now, when I constrict the blood vessel, obviously the blood cannot flow smoothly here. And when I release the pressure after constriction, the blood flow will be very turbulent, and that is because the blood will try to mix, and then there will be churning of the blood, and that will cause vibration and sound. So what I did is I constricted the blood vessel, and when I release the pressure, there will be turbulence, and the blood will mix and it'll kind of try to flow in all directions, and that produces sound. And this sound that we will hear is called Korotkov sound. Korotkov. Korotkov sound. Listen carefully. Korotkov sound is not lub-dub. Lub-dub are separate sounds that were produced by closure of the AV valves and closure of the semilunar valves respectively. This is a different sound that we hear in the arteries by turbulence of blood in the arteries. So this is Korotkov sound. So what's the point here? So obviously we use the brachial artery for measuring blood pressure, right? So the doctor puts in the cuff. So what we do is, as we inflate the cuff, that causes a lot of pressure on the brachial artery, and it actually constricts the brachial artery. Okay, so the inflation of the cuff constricts the brachial artery. Now then you gently release the pressure. As you release the pressure, the blood tries to forcefully come out, or the blood tries to pass forcefully, and that causes turbulence, and we hear the first Korotkov sound, and that sound is called our systolic sound. So that's the systolic sound that we hear. Okay, and then with each systole of the heart, you keep hearing these noises or these sounds until when the last sound is heard, and the last sound that we hear is the diastolic sound. So let's talk a little more about it. Okay, so the average blood pressure of a healthy adult is 120 by 80 millimeters of mercury. 120, the number 120 represents systolic pressure, when there is a lot of pressure on the wall of the artery, and 80 is diastolic pressure, when actually the ventricles are relaxing and we have less blood exerting pressure on the wall of the artery. So the top one is systolic pressure, that's systolic pressure, and this is diastolic pressure. Okay. So how do we do this? Initially, the cuff is inflated, right, to produce a pressure greater than the systolic pressure. So first what we do is we increase the pressure a lot. So we kind of increase the pressure to 150. So it's way above the systolic pressure, so that the artery is pinched off. We increase the pressure of the cuff so much that the artery is pinched off and everything is very silent. The pressure in the cuff is read from an attached meter called sphygmomanometer. A valve is then turned to allow the release of air from the cuff. So now you are gently causing release of pressure, causing a gradual decrease in cuff pressure, right? When the cuff pressure is equal to systolic pressure, which is 120, the first Korotkov sound is heard as blood passes in a turbulent flow through the constricted opening of the artery. Hope that makes sense. So Korotkov sounds will continue to be heard at every systole as long as the cuff pressure remains greater than the diastolic pressure, which is 80. So as you are slowly releasing the pressure, you will hear these systolic Korotkov sounds as long as the pressure is above 80 millimeters of mercury. Okay, when the cuff pressure becomes equal or less than the diastolic pressure, the sounds disappear because the artery remains open and the laminar flow of blood resumes. The last Korotkov sound thus occurs when the cuff pressure is equal to diastolic pressure. So, to review, first you increase the pressure. You increase cuff pressure to over 150 maybe millimeter of mercury. Okay, so at this point you're actually constricting the brachial artery, so blood cannot flow. Then you gently release the pressure, and when the pressure comes down to 120 millimeter of mercury, you hear the first Korotkov sound, and this is your systolic pressure. That's your systolic pressure, which if you are healthy, that should be around 120. Then you keep decreasing the pressure, so you come to 110, 100, 90, and as you slowly decrease the pressure, you should hear these Korotkov sounds for each ventricular systole. So you will hear Korotkov sound for each systole, as long as, I should keep writing here, as long as the pressure is more than 80 millimeter of mercury. As soon as you hit 80 millimeter or less, the cuff pressure is 80 millimeter or less, then you hear the last sound, which is the diastolic pressure. So when the pressure is equal to or less than the less than 80 millimeter, then the sound stops, and that represents your diastolic blood pressure, which again should be around 80 millimeter of mercury if you're a healthy adult. Okay, so that's a concept, or that's a principle behind blood pressure. So this is just for you to memorize pretty much. This is from the American Heart Association. So normal blood pressure is less than 120 systolic and less than 80 diastolic. So in your exam, if I say 119 over 79, is that normal? The answer is yes. If I put 120 over 82, is that normal? No, that's elevated. 120 over 82, that's elevated blood pressure. Stage 1 high blood pressure is when you have the systolic pressure range between 130 to 139 and the diastolic range between 80 through 89. At this point, doctor usually recommends that you exercise, you take care of your health, you don't put on much weight, things like that. And then stage 2 is when it's over 140 systolic pressure and over 90 diastolic pressure. You obviously need medication at this point. And hypertensive crisis is pretty serious. You need to go to the doctor immediately when the pressure is super high. It's higher than 180 systolic and higher than 120 diastolic. When I was pregnant with Rian for the last, I think I was 38 weeks, no, not 38, I was 33 weeks or so. I was diagnosed with preeclampsia and my blood pressure was 190 over 130. So I was obviously on complete bed rest at that point. All right, so that concludes my lecture on blood pressure. I'll start with a new video for the ECG or echocardiogram.